Let us solve some problems of quadratic polynomials. The first question is the product of all real integral solutions of this polynomial. This one. Here x square minus 3x plus 3 to the power x square minus 16x plus 48 is equal to 1. 1 we can write it as x square minus 3x plus 3 whole to the power 0. Now if we will equate the exponents, then we will get x square minus 16x plus 48 is equal to 0. That means exponents are equal. As the base is same, x square minus 3x plus 3 is the base, so their exponents will be equal. Now we can solve it by factorization method. We have to factorize by splitting the middle term of this quadratic polynomial. Here minus 16 is the middle term, and we will choose judiciously two numbers whose sum will be equal to minus 16 and product will be equal to plus 48. That is minus 4 and minus 12. We have to split minus 16 in this way. So you will get this as x square minus 12x minus 4x plus 48 equal to 0. This implies if you will take x as common, then x minus 4 into x minus 12 is equal to 0. So we will get x minus 4 equal to 0 or x minus 12 equal to 0. From here we will get x is equal to 4 and x is equal to 2 or x is equal to 12. There are two integers which are the solution of this equation. So the integral solutions are 4 and 12. These two are integral solutions of this equation. This implies the product will be equal to product of the integral real integral solutions. Product is equal to 4 into 12, which is equal to 48. Hence option 2 is correct. Next question. If the polynomial ax cube plus bx minus c is exactly divisible by the polynomial this one, then which of the following option is true? Here f of x we will write it as ax cube plus 0 into x square plus b into x minus c. This is the polynomial which is completely divisible by g of x, exactly divisible by g of x, that is equal to x square plus bx plus c. Just you go for division, we will get ax cube plus bx minus c. If we divide it by x square plus bx plus c, we will get ax here, it is ax cube plus abx square plus acx. Now subtracting, we will get minus abx square plus b minus ac into x minus c. Now here you put minus ab, so it will be equal to minus abx square minus ab square x minus abc After subtraction, we will get ab square plus b minus ac into x plus abc minus c. Now here this remainder should be equal to 0 for complete division. That means we have to put ab square plus b minus ac is equal to 0 and abc minus c is equal to 0. And these two equations we will get. And from second equation we will take c as common. So this will be ab minus 1 equal to 0. Or c is equal to 0 because here it is also given that c cannot be equal to 0. So c cannot be equal to 0 implies that ab minus 1 equal to 0 or ab is equal to 1. We will get first one. ab is equal to 1. This is the first condition we got. Next is from here ab is equal to 1. Put the value of ab is ab there. ab is equal to 1, that is b. You see here if you will put, that is ab square plus b minus ac equal to 0. We can write this as ab into b plus b minus ac equal to 0. ab is equal to 1. So b plus b minus ac equal to 0 or ac is equal to 2b. This is the second condition. This is option C. Next is, as ab is equal to 1, we can write this as you see ac is equal to 2b, multiply b both the sides. We will get abc is equal to 2b square. And here ab is equal to 1. So ab is equal to 1 means we put 1 into c is equal to 2b square or c is equal to 2b square. That means this is the option A. So all of these options are correct. Hence answer will be option D. Next one is the number of zeros of the given graph. That means we have to check how many times the graph cuts the x-axis. Here this is first intersection point, second, this is third. That means the number of zeros for the given graph is 3. Next one, the graph y is equal to p of x is given for a polynomial. The number of zeros of px, here only it is touching the x-axis, the graph is only touching the x-axis. That means it will have only 1 zeros. Consider this important question. Let us solve it. Find the polynomial g of x from the graph. First we have to extract the information from the graph. And here this is the point where the graph cuts x-axis. And here x is equal to minus 3. Here also the graph cuts x-axis where x is equal to 1. And this is the minimum point. The graph is opening up and this point is the minimum point and its coordinate is x is equal to minus 1, x is equal to minus 1 and y is equal to minus 8. This is the coordinates of the vertex. Now we know if a is a, here suppose a is a 0 of the polynomial, then x minus a is the factor of the polynomial. That means if minus 3 is a 0 of p of x, it implies that x minus a, x minus of minus 3, that is x plus 3 is a factor of p of x. Now similarly 1 is a 0 of p of x. That means x minus 1 is a factor of p of x. Now we will form the polynomial. The polynomial p of x will be equal to k into the factors x minus 1 into x plus 3. Now we have to find out the value of k. The value of k can be found out by putting the values of the vertex coordinates. P of x is equal to minus 8, that is equal to k. X is minus 1 into minus 1 plus 3. So this is equal to k into minus 2 into plus 2, that is equal to minus 4k, or k will be equal to 2. So the polynomial g of x will be equal to 2 times x minus 1 into x plus 3, or we can solve it as x square, that is plus 2x minus 3, or that is 2x square plus 4x minus 6. This is the required polynomial which we will get from the graph.